Hey everybody, and thank you for trusting PAI for your truck part needs. The following video will show you how to install your new PAI injector tubes for Series 60 engines. Let's go! Let's start by thoroughly cleaning the head and removing the fuel injectors. Next, make sure you have the tools and the parts you'll need for the job. Insert the insulation tool into the old tube and thread the pilot into the tip. Then, Knock out the old tube by tapping the pilot with a mallet. And finally, be sure to remove the old O-ring and clean the injector tube hole. Go ahead and lubricate the O-ring, and then slide it over the new injector tube. Then, mount the injector tube on the installation tool and tap it into place with a mallet. Now, install the injector hold-down clamp and tighten it to the recommended torque value. Alright, so for this next step, thread the flaring die into the installation tool and tighten until the tube's end is flared. Next, assemble and insert the tip reamer pilot into the injector tube. Be sure to lubricate the reamer. Then, using the speed handle, ream the injector tube tip. Next, attach the stop block to the fire deck using a pair of head bolts. Then, assemble, lubricate, and insert the seat reamer pilot into the injector tube. And finally, ream the injector seat with the speed handle until the pilot bottoms out on the stop block. Now, you're going to want to remove the excess stock from the injector tube using the tip refinishing tool. And finally, be sure to clean your newly installed PAI injector tube using compressed air. Hey everybody, and thanks again for trusting PAI with your truck part needs. Don't forget to sign up on our website to receive the latest updates, events, and new part releases from PAI.
My name is Erwin Norris. I'm PAI's plant manager for engineering. Today we're talking about our new robot cell here that we got for doing synchronizer housings and synchronizer clutches. Thought about what products we had that we wanted to get more efficiency and also better quality into our products. And from that we decided that we looked at our clutch housings, and I think about that, it's a high volume part for us, and we really want to put it out there to the market that we will have the best high-class product that you can get. Being able to run after hours as well as during the day, being able to automate the system from it picking up the part, running through the robot, machining the parts, deburring the parts, identifying the parts, and most importantly, inspecting every part that comes off of the machine to maintain that quality that we have.
Hi, I'm Kevin Bosey. I'm the CNC programming manager for PAI Industries. Started out with an OKK machining center, added a custom pallet changer, or shuttle as we call it. We added a matrix dock peener to stamp our parts, a CMM to check all our parts, and a deburring station. And it also incorporates a 24-part carousel.
My name is Suyok Salunke. I work at PAI as a product engineer. I develop new parts here. I design the processes for development of new parts. Coordinate measurement machine, it checks all the features on the part to the print specification to the 50,000th of an inch. To explain that, 50,000th of an inch will be 100 or 1,000th part of a hair. So this machine will check the part and its feature to the print specification, and if it is off within few tenths on any feature, the CMM will generate a signal and the robot can separate that part out from the manufacturing bin or processes.
One of the biggest benefits is consistency of the product, because with a robot, it loads the parts the same way every time. Everything is going to be identified exactly the same. It's going to be deburred exactly the same. Of course, like I said, we talk about the quality. We're looking at all those features, so every one that's coming off like that. Being to go full robotic with this and being able to do our lights out operation and so forth, we're able to triple our output on this machine compared to what we had on our normal machines. This is one of our latest new machines that we brought in. This is our Akuma M8600 horizontal machining center. My name is Erwin Norris. I am the plant manager for engineering here at PAI Manufacturing. This machine right here will typically be doing parts that are of complex configurations, forgings and castings, oil pumps, water pumps, cylinder heads. That type of equipment can go on this machine. One of the advantages of a horizontal machine is it has a dual pallet system. We have one pallet out here that the operator can load the parts in, while on the other side of this wall you see here, the actual parts will be machining. As the parts are finished machining, the parts will come up, rotate around, this pallet will go inside, start machining, and the operator can go ahead and unload parts out here. That'll allow him to do quality checks, any kind of deburring operation, all like that, while the machine is running on the inside, and it never has to wait for the operator to do anything else. The probe system for Renaissance is much like a CMM, except for it's on the horizontal machine. A probe can come in after machining of the part. On this part, it would probably touch the bores here, and check the bore here, and check our inside bores. What that allow us to do is you'd be able to check the part, make sure it's in with parameters, and alert the operator if anything goes wrong. This machine has a modular tool changing system. We'll be able to hold 80 tools in the socket. We can expand that up to 120 just by adding a couple trees. One of the things that we've brought this machine for is the next generation in order to automate even further. Instead of having the operator load right here, we can actually add what they call a pallet changer onto the system. So we would have a pallet changer system out here. We can have 4, 5, up to about 12 of these pallets on the outside, and that would give you more lights out operations for better efficiency.
Hello, my name is Brandon Seedorf. I'm with PAI Industries, and this is our new metallurgy lab. We designed this lab because the material structure that we have in our raw materials is very important to the performance of our product. Our product is used in heavy applications like semi-truck engines and transmissions, fire trucks, garbage trucks, cranes, bulldozers, dump trucks, all the very extreme environments. So the products that we make, be it pistons or gears or shafts for the repair of engines and transmissions in these applications, it has to withstand very, very high forces. Any tiny little flaw in the material, down to the molecular structure of the material, could actually result in a catastrophic failure. For example, a small crack that you can't even see with your eye in the tooth of a gear could actually cause that tooth to break off under pressure and cause that entire transmission to come apart or seize up or have some type of catastrophic failure. We've designed this lab to help us have the technology to be able to look at those microstructures under magnification and use different types of metallurgy processes to actually identify what the chemistry is of the metals that we use.
My name is Tarun Sikri. I am the lead metallurgical engineer here at PAI. I am involved with product development, investigating customer complaints, and quality control. The goals of our metallurgical lab includes identifying alloy grades of unknown parts and understanding how alloy inhomogeneities called microstructure affects part performance. This includes investigating questions like what types of soft and hard phases are present in our material, orientation and distribution of these phases, how deep and hard is our case hardened layer for wear-resistant applications such as gear and camshafts. A deeper understanding of how alloy microstructure affects part performance helps to resolve customer complaints, further our product development, and improve our quality control, ultimately providing a better product and service for our customers. So we section a part at a microstructural region of interest. That region of interest could be defined by a specific part we are trying to improve, or it could be based on a customer complaint. The part always breaks at this point and we don't know why. So after you've sectioned it, make sure that you cut it down to a size less than 1.25 inches, and then you mount it or encase it in a thermoset resin, grind and polish it to a smooth finish. And then you're ready for microscopic analysis. There are a few things. The first method is general etching in acid, and the different phases of material will react differently with the acid, creating a contrast when viewed in a microscope. So that helps with alloy identification, what helps to elucidate any material inhomogeneities that could be adversely affecting your product. The other thing is to confirm the hardness and depth of the hardened layer for camshaft and gear applications.
My name is Wei Huang. I'm the metallurgy engineering manager at PAI Manufacturing, and this is our harness, macro harness tester. We use this to inspect a lot of gear at the receiving, and also use it for complex parts in a non-destructive way. And we have different scales with this macro harness tester. We have you have C scale and B scale, and this result can be converted to the mechanical tensile strength pretty quickly. This is our micro harness tester. Difference from macro harness tester is this one is to do the harness testing in micro level. And the macro harness testing tells us how hard on the surface. Micro harness tester can tell us how deep the case depths penetrate into the material. And also it can be used to identify different metallic crystalline phases in the materials in the microstructure level. This is our tensile tester. Tensile testing is a destructive test that can tell the maximum and the yield strength of material, as well as ductility, like elongation of the material. It can tell the full properties, mechanical properties of the material. We use this for our regular inspection, production inspection, receiving inspection, and also for our R&D.
For warranty parts, we compare this information to our specifications and deem, is it a valid warranty claim, or the problem be during the use phase of the product that we need to get back to the customer with. And so I would describe it as more of a collaboration. And so that's where the service part comes in. We aren't just selling a part, we're servicing the customer.